Hello, I'm Nitin Dahad with EE Times. I'm here in the wonderful city of Bengaluru, or Bangalore, as many of you will know, in India, and here for an event called India Electronics Week. But I had the chance to meet up and talk to Madhu, who's the CEO and founder of InCore Semiconductor. Madhu, hello.
Hi Nitin, glad to have you in Bangalore.
Thank you. So there's a lot going on in India, and a lot written in the press all over the world. But I wanted to come down and talk to you about some of the real stuff that's going on. But before we do that, tell me a little bit about you and Incor Semiconductor and the evolution from the Shakti project.
Well, the Shakti processor project was basically started to give India some heft in the whole world of processors, right? We don't have processor architects, we don't have open source designs, so the ecosystem was absent, apart from a few research programs here and there. So the Shakti program succeeded fairly well. In 2018, the founders of the Shakti, the technical team, essentially came out to do Incor based on our expertise, because we felt that we had enough people we could hire and create a world-class processor architecture team in India. That was not possible before Shakti. You couldn't get people who could do processors, right? So we built the ecosystem, and then we leveraged the ecosystem to create a startup.
And I think it's quite interesting because I see people from around the world. I met somebody in Europe who has had some work on Shakti as well. So it's quite a distributed team as well now, isn't it?
Yeah, that was the goal, right? Was to create processor architects and seed them across the planet. It was not meant only for India. If you look worldwide, systems projects in every university has been chopped down. Everybody is going AI, ML. Processor design, operating systems, file systems, database, they're all vanishing. So the universities of the world need to kind of revive systems architecture, because these are the systems that power. And Shakti was meant not just for India, but as a way of India contributing to the world in the field of processors. And Shakti was one of the founding members of the RISC-V consortium. Yeah. So for a country that does not have a history in processor architecture, I would say we have come a long way.
So tell me a little bit more about the Incor.
Incor was started in 2018 as a spin-off from the Shakti program to create processors for not just for India but around the world. There are 3-4 other main players in the world. We felt India could be a strong player in the world. The initial focus was on embedded, going from 50 megahertz to about 2 gigahertz or so. So if you look at the ARM family, that would be anything from a Cortex M2 going all the way till a Cortex A55. So you can straddle deep embedded to something like a small, to a feature phone or even a low-end smartphone. Next step is then to go to higher-end phones and all of that. But the first journey, which will take 3 to 4 years, is this. We are mostly done with it. So what we're doing is innovating further. We are working with Indian companies to create an SoC ecosystem. India does not have too many product companies, right? So if somebody wants to buy an engine meter chip, they have no company to place a purchase order on. So we said, look, we'll adopt the Foxconn model. We'll work with the partners, create a few reference designs, and then go ODM. So instead of going branded products, we'll start with white label, because the energy meter consumption in India over the next 5 years is going to be 250 million parts. And there are 2 parts per meter, 1 RF and 1 metering. So 500 million parts are going to be procured just by one project. So there is enough demand. So we are just not creating processors, we are literally creating an SoC ecosystem in India where none existed before.
And I think that's something which maybe people don't understand, because it's not about creating things in isolation. It's about sort of creating that ecosystem. And I talking to people at this exhibition already, I sort of hear about how India's sort of doing a lot more. I think I heard a figure at the moment, 20% of the world's sort of fabless design is happening in India.
30 to 40 is a more accurate figure.
Okay, and it's there's a target for 2030 to go even bigger. And I think also I heard a term called reverse innovation, which is basically starting with that innovation for Indian markets and then going out, as opposed to taking technology from other markets and then bringing it for India.
So I had a conversation with a German consortium last week. The goal was that we design in India and manufacture in Germany.
and that's the whole point.
That's the whole point, right? So US is going to put fabs, Germany is going to put fabs, Japan is going to fabs. So what's going to happen? Innovation and intellectual property creation is going to come out of India. The slightly lower value manufacturing is going to go to the West. That's a flip.
that will be my headline, I'm sure. But
that's really happening. Because it's interesting. The Western countries are floating in cash. We are floating in people. Right? So I can innovate here. They can put the fabs there. It's a natural fallout of where the money is and where the talent is.
So what do you say is what's sort of missing in the narrative that we hear about India? I mean, the thing we hear is about there's Make in India, there's the Semiconductor manufacturing initiative, and then there's other initiatives. What is it that we don't hear about that I think you're working on the ground?
The courage it takes to innovate and create products. Everybody assumed India and Asia in general does not have it. We are essentially proving that we can conceptualize products for the world, design it, manufacture it, sell it here, and take it elsewhere. In the embedded products, by that I mean chips costing between 50 cents to $15. I think India can easily supply about 25% of the world's markets. That is products conceived, branded in India, manufactured in India, and sold to the world.
And is there a market in India itself for those products?
Huge. Like I said, the energy meter market itself is 500 million chips in the next 5 years. Look, this is not about jingoism or saying localization and all that. We are 1.4 billion people. We are a civilizational entity. Can you imagine 1.4 billion people relying on third-party supplier computing needs? As I said in another interview, back in the 60s we had the Green Revolution. We couldn't feed ourselves. Currently, we need to feed ourselves when it comes to computing and information. Otherwise, instead of food slavery, we'd be trading it for information slavery. I need to control my information. I can't control my information unless I do my computing. I don't know why people don't get that. It's a very elemental need that you need to control your compute infrastructure.
So let's talk a little bit about the strength of the ecosystems that are already here and what you're striving to sort of grow. Tell me a little bit about current status and what it's going to.
Yeah. I'll tell you where the lacuna is, right? I don't know whether you remember, back in 1988, HCL did a 4 CPU box, state-of-the-art Unix, cache-coherent Unix in 1988, ahead of Sun and HP at that point of time, barely. They couldn't sell in the US. They tried. HCL America was actually created to sell boxes in the US, not for body shopping. Once that didn't work, it got converted into a services company, but it's a pure product company. Packaging was bad, manuals was bad, support was not great, right? So India lacks experience in packaging technology products. We do automotive well, we're getting there, right? But creating technology brands, packaging them, customer support, all of the soft bits, the non-technical bits are missing. And then the semiconductor value chain of post-silicon testing, ATE, all of that is also not there. That is slowly getting filled up. So once you have a confidence of doing 2-3 chips, the floodgates will open.
But I think you have been doing a lot of chips. I mean, I visited sites like NXP's design centers and all the design centers here, Analog Devices and Intel. So there's experience already, isn't there?
The experience is in design. The experience is not in product conceptualization. Okay. It takes an enormous amount of courage to say, okay, I'm going to design this part with 2 cores, with these peripherals, in a BGA package, 258, and I'm going to sell it for $7. Okay. It's an act of faith. Yeah. So essentially what has happened in the tech industry is that we essentially chuck the Brits out and let the Americans in. So we went from political colonization to technology colonization, right, in a way. Yeah. So we have tons of people who can design, but very few will have the courage to say, let me do a startup and I'll conceptualize the product, right? That is the missing ingredient. The missing ingredient is not tech. The missing ingredient is product management.
So what do you see happening over the next 2 to 3 years in the design space, and then how does that connect with initiatives in manufacturing?
Multiple lacuna need to be filled. In the design space also, Indian design space is spotty. Let me just... in the sense that there are not too many processor architects at the high end. If you want to do a multi-die AMD type design, there are not too many people around. Packaging knowledge is almost non-existent. So even in the design space, there are multiple lacuna. I'm actually working with the government to see how those can be filled. So we need to fill those up, and we need to fill those up in a war footing. Otherwise, you will not be able to design a complete NVIDIA chip over here or a complete high-end chip. Embedded, we can do well now. That's not a problem. In the manufacturing ecosystem, almost everything is missing. OSAT is coming. With that, I'm hoping all the other substrates, all of those ecosystem partners will start coming in. Then you get the fabs. Fabs is a much bigger deal. Fabs is just not the fabs, right? It's also the ancillary industries that need to come. So people trivialize building a fab. Building a fab in a country without a fab ecosystem is not for the faint of heart.
Yeah.
It's going to take some time on that, correct? So that's there. So once you do manufacturing and design, we got to figure out how to create startups that create products. So that the IIMs, the business schools of India need to step up. We've been looking only at the IITs for inspiration. We've not been looking at the business schools. They're completely missing in the conversation. They need to teach people on how to conceptualize the product. They need to do case studies on what products India needs.
But, yeah, this is interesting because I mean, having myself been based in Europe, but worked in Silicon Valley, and I think a lot of Indians have worked in India, gone to Silicon Valley, come back. There's always been that sort of there's the element of commercialization from the US, and then the technology expertise from whether it's Europe or India. But that's already there. So I think what you're saying is you want to bring all of it together.
Yep. I fail to see why India cannot have a complete embedded chip ecosystem from product vision to manufacturing and supplying to the world. I don't believe in the distributed supply chain when it comes to a large country like India. I think somebody like China, India, US can do everything in one country. Doesn't mean that India should use only its chips.
Yeah.
So even though I have a very strong India vision, I'm thinking we will, out of our consumption, anywhere between 30 to 60% would be locally produced. 40% would come from outside, and it should. I don't want that ratio to go up, because if everything becomes local, the industry here also could stagnate. Yeah. I want healthy competition. That's all, right? So this is not a China-like strategy where saying keep the Westerners out.
Yeah.
I just want a fair playing ground. Now, I got a handicap because I don't have an ecosystem. So the government will have some policies to give a bit of a handicap to the local vendors. But people should not be mollycoddled permanently, right? The training wheels need to come off after 5 to 10 years, right? 2032, 35, the Indian chip industry should only have as much government support as the US gives or Japan gives or something. It should not be giving extra support.
Yeah. For you, I mean, what is it going to take for Incor to succeed? You've developed this, the RISC-V based SoC, and that's kind of like where you connecting with all the different bits of the ecosystem, both in India and elsewhere in the world. What's it going to take for you to succeed doing what you want to do?
For people to start believing in our vision, Incor is a lot more than RISC-V.
Yeah.
We get pigeonholed as a RISC-V provider.
I'm sorry.
Right? So, in terms of the core technology, Incor actually has got something called core generators.
Okay.
And we sell what we call core hubs. Not just the CPU, the Axie fabric, the interrupt controller, all put together, optimized for certain domain. It's completely automated, right? So we have core generators for each processor family. So you can actually generate a processor complex on the fly for anything, right? Then we are building SoC generators. We'll take this and generate a complete SoC. We are working with partners to create an IP ecosystems of pre-verified IP. Hardware verification, driver verification, so that everything is pre-integrated. Then we have automated SoC verification that is coming along the way. The goal is, from concept to GDS2, I want to bring down to 3 months. I want to revolutionize and democratize building of an SoC. Currently, it's too manpower heavy. Why are so many Indian engineers deployed? Because to test an embedded SoC takes 20 people. Yeah. It should take 2. Everybody is talking about RISC-V. Nobody is talking about how do you do RISC-V. The real problem is not RISC-V, right? ARM is not ARM has got some business model issues. It's tough to deal with. But technically, RISC-V is not doing something that ARM has not done so. Correct. RISC-V is accelerating a lot more in terms of extensions. It will overtake ARM in the next 2-3 years. That's not there. But even RISC-V, if it reaches its maximum potential in terms of ISA depth, is still not solving the main problem. Why does it take so much of money and time to build an SoC? That is the problem. There are too many human beings involved in creating a chip. We need to reduce that human element by 80%. That is the problem that Incor is solving, using RISC-V as a base. So our processors are engineered to fit in a AI-enabled process flow. Our processors are not an end to themselves. They are meant to be used in a broader concept. Yeah. I mean, it is not about talent. Is this the best deployment of a human mind? Assuming my entire team of, say, 40 people, they've all won the Turing Prize. Okay, they all have IQ about 160, 180. I have the talent. Should I deploy the talent? Why should a human being route a chip? Is this an activity a human being should be doing? We need to ask some fundamental questions as to what activities a human being should be doing in chip design and what activities an AI flow should be doing. You can't look at it from a perspective of just generating employment. See, chips are too inherent to our society. So they have to be stable, they have to be secure. Look at all the flaws we're getting in chips. That came due to human beings. I can make a case that human beings have bungled chip design. It is time to hand it over to the computers to do a better job. Because if I need to scale up society, if I need to put chips all over the place, I don't think 7 billion people on the planet will provide you enough talent to test, verify, validate all of that. All your Wi-Fi bulbs that are in every homes now, you think somebody's actually done a full chip verification? Somebody has tested the driver for security vulnerabilities? How are you going to? It's an exponential problem. It's beyond human capability to test so many chips and so many combinations.
So now let's shift gears a bit. You're an advisor to various government initiatives on the semiconductor design. I guess more broadly. What's your ultimate goal and vision?
See, we need a engineering ecosystem, right? And I think we got a little carried away. Let's do a 7 nanometer fab. I think sense is dawning now. What we should be doing is look at some bulk semi, silicon carbide, gallium nitride, 300 nanometer mixed signal, electro-optical, MEMS type fabs. Stop at 65 or 40, don't even go to 28. Get 10 to 15 such small fabs, investments of between $500 million to $1.5 billion. Then you will build fab engineering talent, you will build a fab ecosystem. So this is like climbing Mount Everest, right? You don't hit the peak on day one. You build a base camp, right? We have to build the base camp for a semiconductor assault. And that base camp has to be smaller fabs, cheaper fabs, but larger number of fabs. Volume, volume, volume. Old tech, not a problem. We will take all the leftovers from the West. Absolutely not a problem for the next 5 to 8 years. I need to get that. See, we are not the most disciplined nation on the planet. I'll be the first one to admit it. Fabs are the other extreme. It requires extreme discipline. So I need a cohort of engineers who have to be reprogrammed to have engineering discipline. Jugaad and somehow do it doesn't work. If I do 3 fabs, all of them need to have the same yield, right? 98.85% in one fab. Intel does it to a fault, correct? They put a fab across the planet. Within 3 months, it will match the parameters of the first fab. We need to learn that discipline. That is key. Once you learn that discipline, the rest will follow.
But I think the initiatives are in place already in terms of trying to get the ecosystems, the education. I've been hearing about all the initiatives going on.
At a 60,000 foot level, good. But we need to get hyper tactical.
Okay.
You can't say, you can hand waving and saying that I got 20 incubation centers, right? We need to set concrete goals. By concrete goal, I mean 2027, India should ship 100 million local parts into the local market. That should be a hard target. Do whatever it takes, ethically speaking, to meet that target. Everything else is hand waving. You can say all you want, fabs, this and all of that. Are you manufacturing local parts and are people actually buying them? Making a part and keeping in distributor inventory doesn't count. I'm sorry, right? It has to be put in products that have been installed in customer homes. That is the only acceptable yardstick.
But I think one thing that I would say though is engineers are good for doing the engineering, but I think what you've developed that talent for is evangelizing and getting commandeering the ecosystems around that somehow.
Blame my dad for that.
Okay.
He was a long-time CEO. So when I was 14, I'm not kidding, he actually taught me how to construct and run a company in excruciating detail. How to raise funding, how to select a board of directors, how to handle HR, how to handle taxation, right? Everything in great detail. Till he died, he would send me only one thing every year. the latest updates to corporate taxation. Just to make sure that, I mean, he was in his late 80s when he passed away, right? 98 to 99% of our conversations is not about dads and things and all of that. It's always on corporate issues and of practically how to run a company. And he was a very successful textile person. He launched a jeans brand that smashed Levi's. And from scratch, it became the number 2 brand in the country.
Pepe, is it?
No, it was called Trigger back in the right. Once he left it, his ain't gone back. So he would always do marketing of his thing, right? So I grew up watching him create products. So I know how to conceptualize a product, how to create a product, how to do store placement. So I would go with him before Diwali to see what competitor products were getting picked up, shelf space, is it being displayed prominently? Yeah. Is the sales guy pushing my product or the other guy's product? Yeah. So I'm used to being in the field, being in the market. So the reason I can do semicon well is I'm extremely well connected in the distributor community. So I know what chips sell. It's not rocket science. It's just hard work. Yeah. People make this into some big, difficult, genius thing. No. It's hard work. Keep your eyes open, your ears open. Have a lot of humility. In spades. Just listen to what the guys pushing the chips are telling you. Who's buying what? Why are they buying it? How is it getting deployed? Error rates? What kind of support they're getting? See, I don't know whether you remember when linear was around. When you designed a power supply, you would always put a linear part first, not even a TI or an AD. Once the design was successful, if you can't afford the linear part, you would switch to a TI or an AD or go to the Taiwanese second source. Because why? Linear support and documentation was top-notch. Its characteristics were impeccable. Yeah. Right? It is the Rolls-Royce of analog parts. Yeah. They had that reputation. Yeah. It's hard work. Why do you think analog designers and RF designers are all grey-haired people over 40s and stuff? It takes years and years of experience to hone your skills. You won't get a genius 25-year-old kid doing great RF design. The field is so complex that you need miles under your belt. Correct?
Well, just think if you were at 14, you were doing the analog stuff, then you would have been.
No, I was only... actually, I started doing RF. I was a ham. So I started designing superhead receivers and stuff. Okay. Unfortunately, the country didn't have an ecosystem. I still remember first year in college, I was 17, I was designing an SMPS supply. And so I needed a switching transistor of 200 kilohertz. Tough to get in those days. Only GE made one. Somewhere in Bombay, there's a stockist. So when Dad went for one of his board meetings in Bombay, after the meeting, he had to go look in the market to get a part. He says, look, I'm not going to do this again. Find a better way to get a part, right? Then I realized that building products in India, not for the faint of heart. The ecosystem is simply not set up. Yeah. So I very reluctantly switched over to operating system development, design, and all of that, right? So, but processors is always it was on my bucket list. So when a chance came to create Shakti and then Incor, I jumped at it. I didn't think twice because that was the one missing item in my career.
In your
portfolio. Because I built operating systems, I built databases at Sybase. Of course, we built file systems. I built big computers. I didn't build the processors that went into all of that. So now, if you want me to build a supercomputer, I have experience across the entire spectrum. I can do the distributed computing. I can do the processor. I can do the memory subsystem. I can write the operating system. I don't have to depend on somebody to tell me how to build that stuff.
That's good.
Right? So when I conceive of a product, it's 40 odd years of experience that will come in 2 minutes saying, okay, this is what I need to compete against HP in that market. I don't need advice from somebody. I don't need to think for 8 to 10 hours. 5 minutes, you show me a market segment, I'll tell you what the product fit is. That takes decades of experience. I'm trying to figure out how to get that experience into heads of people. This is not an ego trip. Okay, India can't be changed by one person. One person never accounts for... I don't believe in historical figures changing the role of history. Load of nonsense. No human being has ever had any major effect in human history, ever. We like to believe there are great things. I want to create product architects in this country. People who have the expertise and the guts to create products, and saying that we do that in bikes. Bajaj Pulsar is one of the leading two-wheelers in the world, right? Yes. The Chinese clone them in South America. They're that good, right? Yeah. So we are number one in the world when it comes to two-wheelers market. If we can do that for two-wheelers, we can do that for chips. I have no idea why. It's not a technical problem. It's not a capability problem.
Well, Madhu, that's a fascinating conversation. Thank you very much.
Sure. Thank you, Nitin. It's really glad to get some of these things out because people need to understand what it will take to get India to where it wants to be in the chip design business.